Write the solution set of the inequation x square upon x minus 2 is greater than 0. And since we know that for a fraction a upon b to be positive greater than 0, so either a greater than 0 and b greater than 0, both are positive, or we can consider a is less than 0 and b is also less than 0. So in these two cases we can find a upon b is greater than 0, and also we need to consider the denominator b should not be equals to 0 in either case. Now, so here in this problem, x square upon x minus 2, for any x belongs to R, we can say that x square is greater than or equals to 0. Square of any real number is non-negative, so that is x square greater than or equals to 0, means which is positive and including 0. So the denominator must be, so which implies here x minus 2 must be greater than 0, and x minus 2 should not be equals to 0. Here anyhow x minus 2 greater than 0 means x is not equals to 2. So x minus 2 greater than 0, that is x is greater than 2. So for any value which is above 2, this inequality will holds correct. Therefore the solution for x square upon x minus 2 is greater than 0 is 2 comma infinity excluding 2. 2 is not included, okay? Or by using the wavy curve method also we can find this solution so easily. Wavy curve method is explained and you can check out in the description. The link will be given. X square upon x minus 2 is greater than 0. So this can also be written x minus 0 whole square upon x minus 2 greater than 0. So you need to identify the factors here. So in the numerator x minus 0 whole square means we can consider x is equal to 0 is a factor in the repeated factor because power 2 is their even power, and in the denominator x minus 2 is a factor, that is x is equal to 2 is a solution. So these are the 2 points we have to mark it on the number line, 0 and 2, 0 here, 2 here. And now we have to check out the powers of factors. If it is an odd power, the curve will passes from one positive side to negative or negative to positive. If it is an even power, there will be no change. So here start from the right side of the 2, and then at the point 2, x minus 2 to the power 1, so it is an odd power. Odd power means it comes from positive to negative, and again at 0 the power is even power. So if it is an even power, it remains in the same side. There is no change from negative to positive, it remains in the same side because of even powers. And now here we can observe from the graph, this inequality x square upon x minus 2 is positive in the interval 2 to infinity. So from 2 to infinity we can say this is positive, hence solution can be taken 2 comma infinity, where 2 is not included because x should not be equals to 2, the denominator part, right? Okay, thank you. Write the solution set of the inequation x plus 1 upon x is greater than or equals to 2. So which implies x square plus 1 upon x is greater than or equals to 2, or we can also write this as x square plus 1 upon x minus 2 is greater than or equals to 0. So whenever there is an inequality, let's not do cross multiplication to get all the solutions. So let's bring the right hand side to the left side and make one side to be 0. So we will not miss any solution, okay? So x square plus 1 minus 2x upon x is greater than or equals to 0. So that we can write x square minus 2x plus 1 upon x is greater than or equals to 0. that is x minus 1 whole square upon x is greater than or equals to 0. So clearly for any x value x belongs to R, x minus 1 whole square is always greater than or equals to 0, and the denominator part, since the numerator part is positive, since a upon b is greater than or equals to 0, which implies if a is greater than 0 or equals to 0, b must be positive, then only the inequality will satisfy. So that which implies that the denominator x must be greater than 0 and x should not be equals to 0 since in the denominator part. So therefore we can say that 0 comma infinity is the solution. 0 comma infinity is the solution for the given inequation. Okay, or by using the wavy curve method, so we can also solve from here. Take the roots for the numerator part x minus 1 whole square, so that is 1, it's a repeated root, and the denominator x we can say x minus 0, so 0, and start taking the curve from the right side, and at x is equal to 1, since the power is even, so it will be remain in the same side, positive, the positive only, and again at x is equal to 0, since the power is odd power, that is x minus 0 whole power 1, so it changes from positive to negative. And since we required only greater than or equals to 0, so we can consider that 0 to infinity. 0 should not be taken since the x in the denominator part. So 0 comma infinity is a solution. Okay, right. Thank you. Write the set of values of x satisfying the inequation x square minus 2x plus 1 into x minus 4 is greater than or equals to 0. So x square minus 2x plus 1 we can write it as x minus 1 whole square into x minus 4 is greater than or equals to 0. So let us solve this by using number line. Take the number line and write the factors here. X minus 1 whole square we will take it as x is equal to 1, and next x minus 4 we will consider 4. So 1 and 4 are the critical points, are the points we can note it down, the roots. And now by using wavy curve method, start taking the curve from the right side, and at x is equal to 4 we can see that the power of factor x minus 4 is odd, so it changes from positive to negative. The curve changes from positive to negative, and it again at x is equal to 1, so x minus 1 the power is even. Even power means there is no change in the sign, so it will be remain in the same negative side. So from the graph, so from the number line graph we can identify that greater than or equals to 0 means positive, and it can be equal to 0 also. So we can say that x belongs to, so where is positive region, from 4 to infinity, and even at x is equal to 4 it becomes 0, so 4 is included. So x belongs to 4 comma infinity is the answer. Okay, the wavy curve method explanation is given, and in description box the link is given, please check out. Okay, thank you. Write the solution set of the equation modulus of 2 minus x is equal to x minus 2. Let's use the concept of modulus function. Since we know that mod x is equal to x when x is greater than or equals to 0, and minus x when x is less than 0. Similarly, modulus of 2 minus x, consider mod of 2 minus x here, which is equal to 2 minus x when 2 minus x is greater than or equals to 0, and minus of 2 minus x when 2 minus x is less than 0, So which implies here 2 minus x greater than or equals to implies that x minus 2 is less than or equals to 0, that is x is less than or equals to 2, and for 2 minus x less than 0 implies that x minus 2 must be greater than 0, that is x is greater than 2. So we can say clearly that for x greater than 2, mod of 2 minus x is equal to minus of 2 minus x, which is equal to x minus 2. So which is given our question, mod of 2 minus x is equal to x minus 2. But also when x is equal to 2, the unequal left hand side, mod of 2 minus 2, which is equal to 0, and that is mod 0, modulus of 0 is 0, and the right hand side x minus 2, the right hand side let me take 2 minus 2, which is equal to 0, both are same. So which indicates that 2 is also a solution. Therefore the solution for this equation is 2 to infinity including 2. So from 2 onwards, above 2 equals to 2 also we can consider. Okay, right. Thank you. Write the set of values of x satisfying modulus of x minus 1 is less than or equals to 3, and modulus of x minus 1 is less than or equals to 1. So here two inequalities are given. Since we know that mod x less than or equals to a implies minus a less than or equals to minus a less than or equals to x less than or equals to a. So let us use this concept, use this definition for the two inequalities. The first inequality, mod of x minus 1 is less than or equals to 3, implies that minus 3 is less than or equals to x minus 1 less than or equals to 3. And the second inequality, mod of x minus 1 is less than or equals to 1, implies minus 1 less than or equals to x minus 1 less than or equals to 1. So here adding 1 for the inequality, minus 3 plus 1 is less than or equals to x less than or equals to 3 plus 1. So that is minus 2 is less than or equals to x less than or equals to 3 plus 1 is 4. So here you are getting x belongs to minus 2 to plus 4, both are included. And here in the second case, you are getting adding 1 again here, minus 1 plus 1 less than or equals to x less than or equals to 1 plus 1, that is 0 less than or equals to x less than or equals to 2. So in the second case you are getting 0 to 2. So from 1 and 2 we must take the intersection of the both to get the common solution. Set of values of x satisfying the given inequalities. Satisfying the given inequalities is 0 minus 2 comma 4 intersection with 0 comma 2. So minus 2 to 4 intersection with 0 to 2 is, the answer can be taken 0 comma 2 including 0 and 2. So let me explain here by taking the number line. So first solution is minus 2 to plus 4, and the second solution is 0 to 2. 0 to 2. So from minus 2 to 4 and 0 to 2, the common solution you are getting here 0 to 2. So we can consider that 0 comma 2 including both 0 and 2 is the solution. Okay, right. Thank you. Write the solution set of the inequation mod of 1 upon x minus 2 is less than 4. Since we have a property in inequality, mod x less than a implies minus a is less than x less than a. So therefore mod of 1 upon x minus 2 is less than 4 implies minus 4 is less than 1 upon x minus 2 is less than plus 4. So which implies that adding 2 for the inequality, minus 4 plus 2 is less than 1 upon x is less than 4 plus 2. That is minus 2 is less than 1 upon x is less than 6. So here we can find there are some positive numbers and negative from -2 to 0 and again 0 to 6. So the inequalities may changes. So you should be very careful in this. -2 to 0 and 0 to 6. So let us split this into two parts. -2 is less than 1 upon x is less than 0, and 0 is less than or equals to 1 upon x is less than plus 6. So in the case of negative, so if you take the reciprocal of x here, the inequality will change. So here it comes -1 upon 2, and here it is negative side, so minus infinity will get. Or we can also write this as minus infinity is less than x less than -1 by 2. And in the case of positive, so if I take the reciprocal of x here, so the inequality will change here. So here 0 is greater than or equals to x, 1 upon 0 can be taken infinity here. So infinity is greater than or equals to x here, and is greater than, so 1 upon 6. So that is, we can write this as 1 upon 6 is less than or equal, less than x less than or equals to. So infinity cannot be taken is equal to, so infinity is greater than x greater than 1 upon 6, so we can write in this way. So from this both, the solution can be taken. Therefore x belongs to minus infinity to -1 by 2, excluding -1 by 2, and again union 1 by 6 to infinity. So even 1 upon 6 also is not accepted. Here -1 upon 2 is also not to be considered. Okay, the solution is minus infinity comma minus half union 1 upon 6 to infinity. Right? Okay, thank you. Write the number of integral solutions of x plus 2 upon x square plus 1 is greater than 1 upon 2. So let's simplify this, which implies x plus 2 upon x square plus 1 minus 1 upon 2 is greater than 0. So the suggested method is, instead of cross multiplication, we must bring 1 upon 2 to the one side and make the other side inequality 0 to avoid any solution. So let's take LCM for this. So we'll have 2 times of x square plus 1, and here 2 times of x plus 2 minus 1 time of x square plus 1 is greater than 0. So which implies this is 2x plus 2 minus x square minus 1 upon 2 times of x square plus 1 is greater than 0. So clearly the denominator, this is x plus 2, so it comes x plus 2x plus 4. So clearly we can say the denominator is positive. X square plus 1 is always greater than 0. So if the denominator is positive in a upon b, if b is positive, definitely a must be positive to make the inequality a upon b greater than 0. So which implies here 2x plus 4 minus x square minus 1 must be greater than 0. So which implies minus x square plus 2x plus 3 is greater than 0, or we can add here x square minus 2x minus 3 is less than 0. So we can factorize it, x square minus 3x plus x minus 3 is less than 0, x taken common, x minus 3 plus 1 times of x minus 3 is less than 0. So we can write x plus 1 into x minus 3 is less than 0. That is, so if we take the number line representing -1 and +3 are the factors here, are the roots of the factors. So by using the wavy curve, taking the curve from the right side of 3, positive to negative, it changes because the powers are odd powers, and again from x is equal to -1, it changes from negative to positive. And clearly we can observe that the inequality less than 0 will be found between x belongs to -1 to 3. So in between -1 and 3, what are the, since we require integral solutions, what are the integers between -1 and 3? 0, 1 and 2. So therefore integral values, integral solutions are x is equal to 0, 1 and 2. So therefore number of solutions is 3. Number of solutions is equal to 3. Okay, right, thank you. Write the set of values of x satisfying the inequation. So here two inequations are given. 5x plus 2 is less than 3x plus 8, the first one, and the second inequation, x plus 2 upon x minus 1 is less than 4. So we need to find the solution which satisfies these both inequations. Let us solve separately. First one, 5x minus 3x is less than 8 minus 2. So that is 5x minus 3x is 2x is less than 6. So dividing with 2, it's a positive number. So x less than 6 upon 2. There is no change in inequality when you divide with positive numbers. So x is less than 3. So the solution we got minus infinity to 3, the first part. And coming to the second part, x plus 2 upon x minus 4 is less than 4. So we can write here as x plus 2 upon x minus 4 minus 4 is less than 0. So let's not do cross multiplication. So taking LCM here, x plus 2 minus 4 times of x minus 1 upon x minus 1 is less than 0. So which implies x plus 2 minus 4x plus 4 upon x minus 1 is less than 0. So this can be written x minus 4x is minus 3x and plus 2 plus 4, that is plus 6 upon x minus 1 is less than 0, or we can take out common minus 3 of x minus 2 upon x minus 1 is less than 0. Now if I want to divide with a negative quantity here minus 3, so the inequality will change. X minus 2 upon x minus 1 is greater than 0. So by using our wavy curve method, let's draw the line, number line. So minus infinity to plus infinity, and here the points are given x minus 2 and x minus 1. Both are linear factors with odd powers. So we can start taking the curve from the right side of 2, positive to negative, at x is equal to 2, and at x is equal to 1 again negative to positive because odd powers. So the solution for positive can be taken minus infinity to minus 1. So here we can consider minus infinity to 1 union 2 to infinity. So from this is the first solution and this is the second solution, A and B. So from this both we can conclude the solution to be taken as minus infinity to 1, the solution can be taken. From A and B, the common solution which satisfies the both inequalities, minus infinity to 1 excluding 1, and again union, here it's a 2 to infinity is there and it's up to 3. So we can consider to be 2 to 3. Or if you see the number line, let me show here, minus infinity to plus infinity. So this is up to 3 is the first solution, up to 3 is the first solution, and the second solution is taken minus infinity to 1 and again from 2 to infinity. So minus infinity to 1 is, this is the red color shaded part, and again 2 to infinity is this part. So from this we can identify the intersection part, that is minus infinity comma 1 and again union 2 to infinity. So these two areas are the common solution. So minus infinity comma 1 union 2 comma 3 is the solution. Okay, right. Thank you. Write the solution set of the inequation mod of x plus 1 upon x is greater than 2. Since we have a property in inequality mod x greater than a implies x is greater than a or x is less than minus a. So let's use this property. So we have x plus 1 upon x is greater than 2 or x plus 1 upon x is less than minus 2. So for x plus 1 upon x greater than 2 we can write x square plus 1 upon x minus 2 is greater than 0. So which implies x square plus 1 minus 2x upon x is greater than 0, or we can write x minus 1 whole square upon x is greater than 0. And the second case we can write x square plus 1 upon x plus 2 is less than 0, or we can write x square plus 1 plus 2x upon x is less than 0, that is x plus 1 whole square upon x is less than 0. So from 1 and 2, say take it as first and this is second. From 1 we can just give a conclusion that the numerator is anyhow x minus 1 whole square is greater than or equals to 0, but it cannot be equals to 0 because it's a strictly greater than 0. So whereby if it is positive, but anyhow you can say this is positive, the denominator must be positive. So which implies that x must be positive in the denominator, and also x minus 1 should not be equals to 0. So to get the solution and to satisfy the inequality here, x minus 1 should not be equals to 0 and also x should not be equals to 0. These are the two cases, that is x not equals to 1, x not equals to 0 and x is positive. And coming to the second case, from the second case, x plus 1 whole square, again it is also greater than or equals to 0, but again it is in a strictly less than 0. So which implies that x plus 1 should not be equals to 0, that is x should not be equals to minus 1. And also since numerator is positive, denominator must be negative to satisfy the inequality. So x must be less than 0 and also x should not be equals to 0. So the two solutions combinedly. So let us take the solutions minus infinity to plus infinity. So the first one comes as x greater than 0, x greater than 0, excluding 1, x should not be taken, x should not be taken and x should not be taken 0, except 0 and 1, 0 to infinity we can consider. And again in the case of the second, x less than 0, even here also we should not consider x is equal to minus 1, minus 1 is not taken. So overall the solution can be taken all the real numbers. We can say x belongs to all the real numbers except three values. What are they? Minus 1, 0 and plus 1. Except these three values you can take any real number. So this is the solution. X belongs to R minus of minus 1 comma 0 comma 1. Okay, thank you. Write the solution set of the inequation mod of x minus 1 is greater than or equals to mod of x minus 3. So instead of solving, let us solve this by using graphical method. So let me take another graph. Mod of x minus 1. Mod of x minus 1 means at x is equal to 1 you will get 0 and the graph can be taken. So this is how the graph will be, mod of x minus 1. And mod of x minus 3 can be taken. So this is mod of x minus 3 graph, black color one. Okay, now clearly, so here is the point of intersection of these both, that is x minus 1 is equal to x minus 3, mod of x minus 1 is equal to mod of x minus 3. So which will be satisfied for x is equal to 2 minus 1 and 2 minus 3 mod 1. So we can consider this is 2 is the part from minus infinity to plus 2, you can see that mod of x minus 3 from minus infinity comma 2, we can find that mod of x minus 3 is greater than mod of x minus 1, right? And again, from 2 to infinity, from here onwards, you can see that this green color line is more than black color one. So from 2 to infinity, mod of x minus 3 is less than mod of x minus 1, or we can write mod of x minus 1 is greater than or equals to mod of x minus 3. So we can just consider that since it is greater than or equals to, so we can include even the point 2, so the solution can be taken. Therefore x belongs to 2 comma infinity even at the point 2. So closed interval 2 to infinity is the solution. So from 2 onward, from 2 to infinity, any real number whereby mod of x minus 1 is greater than or equals to mod of x minus 3. Okay, right, thank you. Please like, share, subscribe and support us. Thank you.